Okay, in the last video we talked about how a moving electric charge creates a magnetic field. So whenever you have current flowing through a wire, that current creates a magnetic field, a circular magnetic field around the wire. Well, if you think about it, every atom itself has moving electric charges. In the atom, we know that we have electrons orbiting around the nucleus. So these electrons create magnetic fields. Now, the electrons are orbiting in different orientations, and quite often the magnetic field of a single atom will kind of balance each other out, cancel each other out. But very often what happens is the majority of the atoms in a magnet, their magnetic fields are all aligned. If you take a look at this diagram here, what you can see is we've kind of taken this object and broken it up into these little sections, and we call those sections domains. And in a non-magnetic material, the magnetic field of that domain is sort of random. So even though this magnetic field is pointing that way, there's another magnetic field sort of pointing in the opposite direction, like this one here, that kind of balances that one out. So the net result is that there is no magnetic field. But in something that is magnetic, what happens is the atoms in these domains, the majority of them have their magnetic fields aligned. So they're all pointing in the same direction. So the result is one end becomes the magnetic north of the magnet, and the other end becomes the magnetic south of the object. And we create a magnetic field. Now, these magnetic domains can be aligned by an externally applied magnetic field. This is why you probably don't ever want to take your bank card or your credit card and have a magnet near it, because that magnetic field will affect the atoms in your bank card and disrupt the magnetic domains. That's how the computer writes to its hard drive, is by aligning the magnetic domains on the hard drive so that we can read which direction they're pointing. The other things that can affect the magnetic domain is heat. Obviously, if you heat up an object, you start giving energy to the atoms, they start vibrating, and that will randomize the domains as well. And if you violently shake an object, or if it goes through a lot of dropping it onto a floor or something like that, that sudden impact will shake all the atoms and randomize them as well. So if you've been out to a restaurant, you may notice that your cutlery, your knife and fork, become magnetic sometimes. Here's a video I shot. You can see the knife and fork are actually magnetic. They're attracted to each other. So again, what's happening here is the restaurant has a big collection of knives and forks, and they all get thrown into a big drawer together. And all of that friction of them rubbing together causes their magnetic domains to align, and they become magnetically attracted to each other. Same thing happens a lot if you go to the hardware store and buy screws or nails in bulk. Because they're all thrown into a big basket, and the friction of them rubbing together causes their magnetic domains to align. So this has implications as well for the Earth's magnetic field. So the Earth's magnetic field is created by the molten magma in the core of the Earth rotating due to the Earth's rotation. So it has a big section of moving electric charges, and they create a magnetic field. And what scientists have discovered is that if we look at the molten lava magma coming out of the Earth's crust, quite often we see strips. So it comes up from the Earth's crust. This is in the ocean, in the mid-ocean ridge. It comes up, and the Earth's crust is spreading apart at this point, which is why we have magma coming up from below. So you can see the Earth's magnetic field is pointing in one direction in these strips as it spreads apart and cools. But suddenly, every so often, we see a strip that is in the opposite direction. So these white strips are the reversed magnetic polarity. So quite often what happens is the Earth's magnetic field actually changes its orientation. So while right now the Earth's magnetic field is oriented so that it is a south pole at the north and a north pole at the south, every so often what we see happening is this magnetic field collapsing and changing direction so that the north becomes an actual north magnetic pole and the south becomes an actual magnetic south pole. And this is the focus of a Hollywood disaster movie called The Core. So in this movie, a typical Hollywood disaster movie, the Earth's magnetic field is collapsing, and the Earth's magnetic field actually does provide a lot of protection for us. It's like a big magnetic shield around the Earth, protecting us from solar radiation coming from the sun. So whenever this collapse happens, the Earth's magnetic field collapses and changes direction. That leaves the Earth open to a big blast of radiation from the sun. And that's what this movie is about, is the radiation coming from the sun. It's going to cause havoc with the Earth. And they have this team set up to go back, drill down into the center of the Earth and restart the rotation of the Earth's core. That's a little bit far-fetched, but the science behind the Earth's magnetic field changing direction is actually correct. So in the next video, we'll talk about how does the Earth's magnetic field actually protect us from radiation.